In the last lesson, we introduced matrices, and today we're going to learn how to multiply matrices, talk a little bit about why that's important, and then we're going to move on to chapter 10. But one of the things we learned the other day is that we define or name a matrix by the number of rows times the number of columns it has. So in the top example, you have 3 rows, 4 columns, so it's a 3 by 4 matrix. A has 2 rows, 1 column, so this would be a 2 by 1 matrix. B has 1 row, 2 columns, so this would be a 1 by 2 matrix. And C has 2 columns, 2 rows, so this would be a 2 by 2 matrix. And the reason that's important is because you're going to see there's only certain matrices that we can multiply together. So we'll talk about the rule quickly, and then on the next slide in our first example, we'll start to see why this rule applies. So if you want to multiply matrices, you can only do it if the number of columns in A is the same as the number of rows in B. And you can see that here. The easiest way to visualize that is the way they have it here, right? Where you have your first matrix and your second, and the number of columns in A is the same as the number of rows in B. And if that's not true, you cannot multiply the matrices. So we'll just look at these examples down here. Which products are defined? A times B. Well, A is a 2 by 1. And you want to multiply that by B, which is a 1 by 2. And since the number of columns in A matches the number of rows in B, that would work. We could multiply that. For 2, B times A. Well, B is a 1 by 2. And we want to multiply that by A, which is a 2 by 1. And again, because the number of columns in the first is the same as the number of rows in the second, we can multiply those. However, in 3, A times C, we would have a 2 by 1. And we would be trying to multiply that by a 2 by 2. And notice the number of columns of the first one does not match up the number of rows of the second. And so we could not multiply that. And so that's not going to make much sense right now. But keep that in mind. We're going to do an example on the next slide. And then it'll start to click why we can only multiply certain matrices by other certain matrices. So if we look at this example, multiply 2 by 2 matrix by another 2 by 2 matrix. And we're just going to walk through the steps. So the first thing you do, and this is not quite as intuitive as addition and subtraction. And so this is something where you're just going to have to memorize the process, but it's not too difficult, so just follow along here. So in this first spot, what's going to go there is the first row multiplied by the first column of your second matrix. So you notice 1 times 2, and then you're going to add to that the 0 times negative 1. So we're really distributing here. But again, this spot, and this I like to think of it backwards. I like to think what goes here in the first row and the first column. Well, it's going to be the first row of my first matrix multiplied by the first row of my second matrix. So in my next spot for step 2, here, right, this is my first row and my second column of my product matrix, right? But what's going to go there is my first row of my first matrix times the second column of my second matrix. And again, you can look at how this is really distributing. It's just like how we distribute. Okay? So you should be able to guess what's going to happen next, right? We're going to have to move on to this spot. And what's going to go there is this is my first row and my second row and my first column. So I'm going to be multiplying my second row by my first column, and that's what I'm going to end up there. So you have the 4 times the 2, and then I add to that the 5 times the negative 1. And then that last spot, working backwards, right? I'm always working backwards here. I think that's the easiest way. I think here, this is my second row and my second column. So what's going to go there is I need to distribute my second row of my first matrix by the second column of my second matrix. So it's 4 times negative 3, and I'm going to add to that 5 times 8. So again, I'm thinking of this backwards, right? I'm going to write my matrix out, and I'm thinking what's going in each spot, and then I'm going to go and get that information, distribute the proper row and column. And then at the end, all you have to do is just simplify what you've got. So for instance, in the first row, first column, you end up with 1 times 2 is 2, plus 0, and there is your 2. And so you ended up with your solution or product matrix, your result is another 2 by 2 matrix in this case. Okay, and we can see here, you should start to see why we can't multiply any matrix by any other matrix. Because if we look at this example up here, we have a 2 by 1, and we're trying to multiply that by the 2 by 2. This was the example in the first slide we said wouldn't work, and we should be able to see here why it's not going to work. Because the first thing I'm going to want to do is multiply the first row of the first matrix by the first column of the second matrix. So I'm going to go, okay, this is the first row. Notice in my first row there's only one thing, but I need to multiply by this first column, but now there's two things here. So I go, okay, well, I do -3 maybe times the 6.7 maybe, but then I'm going to add to that what? There's nothing else in this row. So what would I multiply by the -9.3? There's nothing there. There's nothing in the first row of the first matrix to multiply by the -9.3. And that's why it's not going to work. It's not going to align. That's why the number of rows in the first matrix needs to align with the number of columns that you have in the second matrix.